Thanks everyone for joining in another week. Only a few people here, but maybe more people will join as we go. Okay. So first, this is going to be the next few weeks is canceled. You probably saw because next week's U.S. holiday, and the following week I'll be away for travel, and then the following week after that is the Thanksgiving week for the U.S. So our next meeting will be December 1st, and we're going to have a speaker from a new colleague from Italy that's going to talk about some mitochondrial carrier um, drugs he's been looking at related to long COVID. So stay tuned for that. And then we're going to have probably Nydia sometime in December talk about this paper that came out earlier this month about the Malta SARS-CoV-2 transmission changes over time in Malta and how that relates with the traveling and things like that, which is a nice little paper we put out with some people in our group. As I've been saying the past few weeks, I'm trying to organize a meeting for the summer 2024. It's most likely going to happen, but I'm still waiting to get more sponsors. But the host will be University of Malta, so it's not about COVID, but it has COVID in there. But it's about regulatory RNAs and everything from mitochondrial origins of life to infectious diseases to space. So people that know of any sponsors, let me know. I could share the slide deck with you, and you could share with them. So okay, let's dive into the news. We got, if you haven't ordered your free tests in the US, you can still order that. So, and that's probably a good thing. It's probably a good test because as the news has been reporting in a lot of places that, they're expecting to have a rise coming up due to the holidays and things getting colder, and COVID and cases are going to go up along with flu cases potentially. So people are urging, get your boosters if you haven't with the new updated vaccine and test. So some of the hotspots right now in the U.S. you can see is this kind of centrally in Wyoming, Montana, Colorado, and other places tend to be right now that we're basically on hospitalization rates for the COVID related some hotspots there. And this is a no-brainer here for us, but this is pretty good comprehensive study came out again looking at masking and during the pandemic and how again another study showing that proper wearing masks properly can actually reduce your chances of exposure, which is again related back to here. And they did a literature review basically based on many different aspects of the community, mask mandates, and so on. And then they created a table like this, looking at laboratory models, references, and looking at the different aspects of it and what cases can be better enhanced or not enhanced with masks. So it's a nice little paper again showing the effectiveness of masks, as we know. Okay, so this paper came out here. This kind of a view perspective paper on this paper. It just came out yesterday, or is it today? Yesterday. Okay, don't know. Forget the date. But so this talking about how they did a study in macaque, the primate model, and they basically looked at how they found that in BALF, the bronchoalveolar lavage fluids, that looked at macrophages after 6 months, short time point and then long time point afterwards. And basically they found, one of the arguments, or not arguments, but discussion points that people have is, we know the virus particles of the virus exist in the body and tissues long after exposure to the virus has left your system. It's been shown over and over again. But is that virus replicating or not, that has been sort of up for debate. And these people here in this monkey model, the macaque models, show that in the bronchial lavage, that the macrophages post-infection, the viral is propagating. The virus is actually propagating. Get it propagates. There's a figure showing something of that context. And they isolate it from the bowel fluids. So that's interesting to see that there's some evidence of this now potentially showing viral reproduction happening long after the virus leaves the system. And then they also go in this intricate detail looking at how potential the MHC, as known compatibility complexes, are heavily involved with the viral persistence in the lung and causing downstream effects where interferon gamma and can impact the NK cells and the behavior of your impact your immune system in the body. And what they say is this whole persistence of SARS-CoV-2 in the macrophages is mediated by the interferon gamma. Here's another plot from there some of the key factors they see long term, which I guess is related sort of to our inflammation paper that we just submitted. Some factors we see here pop up like CXCLs and things like that related with immune and inflammatory behavior.
Option.
Yeah.
Why is that called why do they refer to that as a miscommunication? Exploiting the miscommunication that it's a pre-existing condition.
It's not a pre-existing condition. There's no pre-existing. SARS-CoV-2 is not a pre-existing condition. You get infected, and then it's a long-lasting impact, right?
Yeah. So
that's long
miscommunication. What's the miscommunication?
From the immune system, it dysregulates. So take a look at the paper, read the paper, and then take a look at it. But it's basically the immune system that it dysregulates because of the MHCs.
Major histocompatibility complex.
Right. So that's where it gets dysregulated, and it causes this dysregulation in the immune functions.
Oh, okay, thanks.
Achin, I guess what's really interesting, the evolution of this question of persistent virus, I guess it's becoming more compelling that they really does have persistent virus now, macrophages and other tissues. How much have we missed? I mean, in other sites that we presume virus is gone and it's a lasting effect. Yeah, and or did they look at whether this is replicating virus rather than say intact virus particle, or is this another example?
That was the main thing of this, is that when they removed the, they took, when they had the endpoint for the macaques, they removed the virus and then saw it was actually replicating from the bronchoalveoli.
So they tested it for replicative.
Exactly.
Yeah, I say that's interesting.
Yeah. Well, which those other papers you mentioned that didn't really show that, right? That was the question.
Right, or it was very controversial. What they did show, it wasn't accepted by everybody as real showing of it, but isolating it and seeing it infected, I think that's pretty good.
But someone might argue this is a macaque model, not human. So you're showing it an animal model. That's the only caveat that you should take away from that. But macaque model and the SARS-CoV-2 infections are pretpretty close to humans from what they've shown, right? Yeah. So that's the only thing. They didn't show it in humans. So other than that, is it showing replicating virus 6 months later? Yeah. At least in the macrophages. They don't look at any other organs though. That's the other thing. So they didn't look at
relatively want to non-invasively test certain immune cells in humans if this is the case. And I don't know if other people are doing that, or have you seen reports on that?
No.
Isolating macrophages or T cells or whatever you want to look at.
Right. Yeah, no, I haven't seen too much of that. So maybe that's something we should see if we get samples on. We can do after getting some grant money.
Yeah.
I just want to say a macaque model is better than other monkey models, but maybe not as good as a chimp model, for example.
Right.
Did they evaluate different strains, and if not, what strain did they look at?
They didn't do different strains, but I didn't read the methods in detail which strain it was. So we have to go back to the methods and look at it, Kevin.
Yeah.
So.
Yeah.
But there's only one strain they looked at. They didn't look at multiple strains.
Yeah, that's kind of unfortunate because some of these differences in the literature might have something to do with strains as well, and it's not really been addressed thoroughly. But
I didn't know that, so that's good to know. Yeah, I'm by far not an expert in these primate models, so that's good.
Question related to that, which is anecdotally, I had a friend who came down with COVID, forget, October sometime. Anyhow, she continued to test positive on a rapid test for, a good 6 weeks, maybe 8 weeks after her.
Wow.
She just continued to test positive, even though she had recovered from symptoms. After a while, now, I'm not sure I would have done the same thing she did, but, after a while, she just decided, okay, I'm clean. I'm going to go back into society. I probably wouldn't have done that myself. But question is, has anybody heard of this? Apparently, it's a pattern that's well enough known that her doctor warned her about it. that she might test positive for a prolonged period of time.
Mhm.
And I'm just wondering whether the paper that you were just discussing gives us a possible explanation of how people are testing positive a month or a month and a half after their acute illness was resolved. And what does,
yeah. No,
I
go
mean,
ahead, sorry.
I don't know if she was I mean, my understanding was a rapid test, if it's positive, that means you are potentially infectious.
Right.
I'm not sure it makes any difference whether you've already been sick or are currently sick or will be, it's like, isn't that true regardless of when you take your test? So I was a little bit, let's just say, concerned when she decided she was, good to go after a month and just resumed a limited social contact. I thought that was maybe risky, but I don't know. I don't know what other people have heard in this regard, but
yeah, I mean, there was early on, like COVID, there've been cases like where people were testing positive with PCR for a year, like that one guy, had the longest, and supposedly he was transmittable at that point for the year, if I remember correctly. I don't remember; it was a while ago, but I mean, I know. Yeah, this paper doesn't talk about that aspect. Obviously, they didn't test the monkeys and they didn't look at with the antigen test. But I mean, there's some. I guess there's two group of thoughts there. One is I've heard from, I don't know which is right, but one is towards the end of your positivity test, you're not transmitting anymore. It's this residual kind of left over from positive virus sitting on, but it's not transmittable. That's what I've heard. How true it is, I don't know. And then the other one is, you're still testing positive, you're still transmitting. Whether it's which one is true, I have to look and find literature. Yeah.
So, the argument has been that those home tests, that the protein hangs around so much more than the mRNA that it's simply residual protein. In fact, Hopkins has a policy: if you're infected, you stay home. After 5 days, if you're feeling okay, you're cleared to come back. They tell you come back to work. And and the home test doesn't count. If they say, if you really want to check it, get a PCR, get the formal PCR. But I don't know what's right here. I'm just telling you that it airs both ways.
And I heard that the protein residual thing definitely might be some case, but again, I don't know how conclusive that is. Right. But I guess the thing that Steve says, get a PCR test if you're after 2 weeks. If they're still showing up positive as an antigen test, I would say get a PCR test, and that would maybe the definitive proof there if you're really transmitting or not.
Well, okay, I may be simplistic in my understanding, but my best guess is if you're positive on a home test, it's like near 100% guaranteed you're going to be positive on a PCR.
Well, not necessarily, because people have shown otherwise, not necessarily. So because as Steve says, the proteins left over, right? There's been residual proteins, and people have, there's been papers that discuss it. How confident people are in those papers, I don't know, but they discuss that.
It may be the compromise is that I think you've raised a question that's legitimate. I think more often than not, they may not be infectious, but how many times is it a sign that they could be, and how do you try to most formally rule that out? Yes, it's really. I don't know if anybody's done a good study of that. There's another straightforward but really important study. If you've got somebody 6 to 8 weeks out, and you've got a group of these individuals, and they test positive on the home test, what's the incidence that they do have a positive PCR test? How else do you test for infectious and virus in these people in the areas of the mouth or the nose where they could be infectious? Seems like a problem that needs to be worked out to me.
Yeah, I agree. So we don't really have an answer for you, Hannah. We have some theories and maybe potential ideas, but no real definitive answer to either way, I guess.
And actually, one of the big ideas is that if you can protect your immune system or do things to support your immune system, then you minimize your opportunity for an infectious reaction to an exposure.
No, that's not very I wouldn't follow that advice. So
You know,
no, I mean, so people get everyone's different. Just because you protect your immune system doesn't mean you're going to avoid infection. No. Hey, Secret, you have your hand up.
Yeah, so it's kind of a question for Steve, which is if are there other diseases where you can, basically convert your immune systems so that you recognize whatever antigens related to that disease as self so that you don't fight infections? It's kind of an immune, this virus definitely dysregulates your immune system. Are there
Well,
cases of
I'm
immune
not a maven in
dysregulation?
the area. Certainly, there are forms of immune deficient disorders where they can do that. And some of the things where you've really got to rev up the system. Then there are things like people with autoimmune, rheumatoid arthritis. For personally, my wife has a high activity of rheumatoid arthritis virus. She's had COVID 4 times. So if I had a positive test at home, I'd have to worry about that more. It's a scenario of comorbidities and what you're dealing with. Yeah, I'm very careful, probably more so than I would be otherwise because of her. So all these scenarios are really difficult. Yeah. And I'm not sure you can improve the RA or lupus individual. What do you do to rev their immune? Unless you have to transplant them or something for some reason. I mean, it's very difficult. Others may have more experience with that. But
so does she continue to test positive on,
she has had the long self-test, but the first time that happened, if you did the PCR and it was negative. So she is an example of someone with a definitively positive home test with a negative PCR. And she goes back out into activity. She's she's a professor and cancer researcher too, and she goes back to work under those situations.
Yeah. So I should have recommended to my friend that she get a PCR. And I mean, it's too late now, but
yeah.
A couple of weeks ago.
Next time, if there is a next time.
Yeah. I didn't realize that the PCR would give that much more than what you find out from a home test. I also should mention she has her own PCP, so there's no reason I should be giving her any advice whatsoever.
That's okay. People are always welcome. Yeah, Kevin, go ahead.
Yeah, I think this is an interesting conversation, and to relate it back to animal models, particularly monkey models. I have not read the study that Action just reported, but one of the great concerns I've had over years is that a lot of studies will include animals that were wild caught and lab reared. Sometimes they only use animals that were wild caught, and sometimes they only use animals that are lab reared. For studies that use both lab reared and wild caught animals, the wild caught animals can have exposures, stress exposures, and other environmental exposures that immunocompromise the animals, and it's not always well understood when those animals are used in studies. And so I've been complaining for years now with the national academies and their organizations that greater standards need to be used because if you've got mixed controls, that could greatly skew your results. And again, I don't know about this one particular study, but again, I would caution people when they read particularly primate model studies and they're using wild-caught animals and lab-reared animals, you could get a differential effect simply because you've got differential exposures across the cohort.
Yeah, it makes sense. It's a good point.
It's interesting.
Yeah. Thanks, Kevin. Okay, so that's good conversation, discussion. I think, Sigurd, your point is more complex. It's a good question, but it's complex. Okay, so there's this other study that came out talking about relating outcome for COVID patients and type 2 diabetes and showing basically your any SARS-CoV-2 antibody levels they discuss here is inversely correlated with that. So, which makes an argument that make sure you get your boosters. So that could decrease your chance from getting type 2 diabetes. which is what this cohort study did. I mean, it didn't look at the biology. Again, they looked at questionnaires from a bunch of patients, and then they really did a correlative study of people who developed diabetes versus didn't. And then one thing they did look at was the creatine levels of this NT-pro and B to measure, when the hospital measured to measure their antibody levels that was there for spike antibodies. So that's it's a nice little paper to discuss, to bring up the fact that, you should probably keep your antibody levels high, meaning keep your boosters active and get your shots, because the lower you have that, the higher chance of type 2 diabetes you could get, according to this study, if you get infected with SARS-CoV-2. Some long COVID news. There's this study here, which is this study here. Sorry, this +1 study. They did a analysis trying to, because the numbers have been still, nowadays. Some people say it's 5% chance to get long COVID, and there's 5% population are getting it now. Previously, before vaccination and stuff, we knew it was like around 20 to 30% of people, at least in the U.S. And nationally and internationally, had long COVID. But now these people did a pretty comprehensive study. This paper came out yesterday looking at U.S. and long COVID, and they basically found out that 14% of people have currently in the U.S. long COVID. So that's higher than that. What was thought was occurring these days. And what they did, they looked at I forgot how many. They looked at a few thousand patients with long COVID and non-COVID and short COVID and so on, and then they categorized these percentages here. With and without vaccination, what are the cases? So this 14%, for example, they say anxiety nearly every day they were vaccinated, and 14% of those people, the population, will have that. Even when you're vaccinated, have this long COVID anxiety issue. And there's other things they looked at on top of anxiety, like other long COVID type symptoms like fatigue and other cognitive issues and other things like long COVID. So interesting paper there looking at that. This preprint came out. It's a preprint, but it's an interesting preprint looking at potential biomarkers for long COVID. So they looked at, on this preprint, these complements activation for these 4 complements that are significant here. The IC3B. I'm not an expert in complement activity and complement proteins, so someone who might be more of an expert might comment on these. But what they found is that potentially in long COVID, they looked at long COVID patient cohort under control, meaning not long COVID. And they found that basically these 4 in the plasma might be a good biomarker. And then they used some ROC curves and other kind of algorithms to potentially say in their predictive power that there's a 78% or 78.5 is the standard findings. There's a percent chance that if these complement 4 protein complements are up in your plasma, that you will have potentially long COVID or be susceptible, or maybe not susceptible, but will have long COVID. And then so they did a few other analysis in here looking at it's a preprint, so keep that in mind. But they looked at other complements and regulators of these complements they looked at that were up compared to long COVID and their controls in the plasma. So I don't know if people have. Yeah, go ahead, Kevin.
Well, I not to be a little pedantic here, but
go ahead.
Again, I'm curious about strains because there's been observations that, for example, acute symptoms differ between strains, and I've wondered for a while now whether long COVID associated with different strains might also express different symptomology. And then
you mean different strains of the virus, right? So
what's that?
You mean different strains during the time of infection of the virus?
Yeah. But again, I've been kind of hoping that the scientific community might better address that, particularly with long COVID. But
so this is a preprint. So that'd be, if you're a reviewer of this paper, you might want to suggest that to them look at.
Yeah, exactly. And I mean, it's not just, of course, it's not just biomarkers. It's
right.
Symptom constellations. So neuropsychiatric symptoms, other types of symptoms. How might those differ in long COVID between that are caused by different strains? It's something.
Yeah, I didn't read the methods in detail, so I don't know when these long COVID patients got infected. I'm assuming it must have been during one of the earlier strains, right? Because it's this.
Yeah, that's what I would assume. But yeah.
Question, Austin, and I don't have it up in front of me, that goes with this discussion is the EPIC data. I can't remember in the blood. I mean, more and more, I think we all know, not just the inflammation, that the acute COVID is really one thing, is the disease of leaky vessels and thrombotic potential.
Yeah.
And the complement and its interplay really plays into this. And long COVID patients to varying degrees may retain that. Did we see these specific pathways, particularly with the complement, a couple of things that would bring that pathway up, and others in the EPIC data in the periphery? I don't have it up. I don't remember. Smacks to me that we did see some of the markers in the ones that where they had the long duration samples.
I have to go back and check. I don't remember.
But it
Maybe,
might be
yeah.
worth looking back at that.
Yeah.
Because it might relate in a human setting. At least might be revealing.
Yeah. No, that's a good idea. I'll do that after this.
Yeah,
Take a look.
I think we did. Yeah.
I do recall. I think it did pop up. I didn't pay too close of attention because I'm not a complement expert. But now that you mentioned, I should go back and look at it. Yeah. Okay. But I mean, again, this is I think the points we bring up for this paper is good. But Kevin, you brought up others. But yeah, take a look. It's preprint, but interesting. Yeah. So I'll take a look at these markers of the EPIC data. This is a new review that came out on long COVID. It's a nice review. I mean, talking about potential long-term health outcomes. Again, going over long COVID versus acute, looking at summarizing the different organs that are impacted and the viral reservoir idea. They talk about I'm not replicating, but the viral reservoirs that are causing the issues with the inflammation, autoimmunity, and so on, and then how different impact of the different organs there are. So this figure summarizes that, like muscle loss, sarcopenia, liver, and things like that. And then management. One thing they still don't mention in this review is they mention mitochondrial twice. So they completely missed that point. So, which means we have to keep hammering that out. I thought after our paper came out, more and more people might start paying attention to that, but they don't mention that. They mention chronic fatigue syndrome, and how that's related to long COVID is related to that. But then that's when they mention mitochondrial twice. That could be related. And then that's it. They forget about it for the rest of the paper. So they're disappointed in that, but the rest of the review is good. So I can be critical in that aspect.
Yeah, because all these other problems are related to mitochondrial dysfunction, most likely.
Yeah, they very well can be. So yeah, they're looking downstream of it. People missed the upstream aspects of it. So, but it's still a good review. So for people to look over and see what's there in the current literature. This is just kind of a short little paper that they're talking about long COVID half-life and how well it improves. This is a news article on that. And this is a plot. And this is sort of just as, I guess, Kevin, your point, looking at the different variants or strains of the virus that are there. And one thing they looked at the virus and tracked it over 1.5 years from different patients, and they saw that more than 50%, here's the highlights, more than 50% of the long COVID patients failed to improve any outcome, regardless of the plot for that, regardless of any of the variants from the wild type or the original strain to Omicron. So that's saying potentially long COVID, because there has been, some people have theorized that maybe Omicron causes a less impact for long COVID than other strains like the original strains, but they're saying for half the patients doing long COVID, the strain has no impact on how long it lasts. Yeah, go ahead.
I mean, I think more studies like that need to be conducted. What's the N out of curiosity?
Oh, I forget. I have to go back and look. Sorry, I have to go back to the method. But I think it was like
no, that's right.
1,000 or something patients or something like that. But I don't quote me on that. I have to go back and look at the paper.
Yeah, that's fine.
Yeah. But it was a good number, from what I recall. But yeah, but they had other. This is just one plot here, but they looked at other ways of looking at the outcome. For example, poor health outcome, long COVID outcome versus good, and they're again showing that that 1.5 years after the infection, it didn't matter for the strain at all. So yeah, I guess first paper that I've seen saying that your outcome for COVID might be strain independent for long COVID, I should say. Here's another paper that just came out, Scientific Reports. If you recall, was it last week or 2 weeks ago, one of the papers came out showing that with long COVID patients, your serotonin levels were heavily suppressed, and it was related with the gut the gut profile, and talking about the gut and brain profile. And in this paper, they actually, this paper came, I doubt they're referring to that one. They knew what was happening in a serotonin paper, but because I think these papers are very close coming, maybe they saw a preprint. But what they did here is they gave it serotonin reuptake inhibitors to the patients. And they found out, they looked at 95 patients, so not a big number for this stuff, but they basically saw improved outcome for some of the long COVID patients that are there. It's kind of a pie chart looking at that. And then some of the ways the symptom scores, meaning before and after, how they've changed or improved depending on the long COVID symptoms. Hey, Sigrid, you have your hand up. You're on mute, by the way, Sigrid, if you want to ask.
Yeah, sorry. My question was kind of something, a reflection on something completely different. So if people have questions about the serotonin reuptake inhibitors, etc., go to them first. But
no, go ahead. Go ahead.
So my question was more about if any, during the first phase, that there were so many people who just had such absolutely horrible outcomes. And I'm just wondering, how much of that was just because they didn't know how to treat it, and so the question is whether that first strain was much different, or just that our standard of care has changed, and so it's very clear how what the phases of the infection are, and then how to treat the different phases, so you don't end up with 80 million people on ventilators. No, not 80 million, but
right.
That you don't end up with people on ventilators as often. So is there anything that addressed, any papers that you've seen that have addressed the changes in severity, or from strain to strain, vis-a-vis care?
Well, I mean, I think it's both, right? I think one was people have figured out better ways of treating it than the beginning, right? And the other part is, people have shown that potentially the virus has evolved, so it might not, it's not as lethal, but it could cause long-term effect. I mean, viruses, if a smart virus doesn't want to kill the host, right? It wants to keep the host alive so it could propagate to different hosts as it goes. And I think this is what happened now. Like, I think the virus, there's papers that showed the I guess lethality, put in quotes, the virus strains have been, like the Omicron is not as lethal, but it's easier to spread. It's become obviously more transmittable even than the original strains, which is from all the mutations that occur. But there's always the theories too that there's a 20% chance, people are saying, that we could have a next Omicron level event with that huge spike that happened back then, and have something that could evolve enough mutations that could cause the same lethality as the original strains that did, and then we won't be prepared to counteract with the therapeutics we are trying to come up with. So I think it's a combination.
Do you know if that's like in any of the reviews that you've read? I haven't had a chance to do much reading, but that's why I come to these meetings. So just wondering if there are any that you could point me to that might address that question.
I gotta find some, but yeah, there's some out there, the papers, and talking. There's papers that have come out the past year or so talking about the viral evolution and looking at that. So, and then the healthcare wise, I don't know if there's reviews or more like what the media has said and what is known, about therapeutics. I mean, Eric Toppel's review in long COVID, they talk about some therapeutics. That's a big, nice conference that came out in the beginning of this year, or earlier this year, I should say. And they talk about really nicely about the therapeutics that are there, and you should actually.
I always listen to TWIV and Daniel Griffin's clinical update, and he always goes. Pardon?
Is one good blog to look at if you want to see this stuff is Eric Toppel's blog, Ground Truth, and he if you go back to what he's been posting, some of the older posts address some of the issues that you just mentioned, and he has like really nice references in there to say, oh, look at this paper, look at this paper, look at this paper, and this is what's happening and evolving. So his blog is a good blog to, and it's all archived, so you can go back and see some of the older ones.
Great, thanks.
Yeah. So that's it for the papers I saw so far in the news. Just go to the strains. We know, at least in the US, I think the rest of the world is following along nicely there. That the main strain that's popping up is now HV.1, which we'll go into in a second. And looking at the wastewater in the U.S., still have to find a good site for the European sub. I know Italy has a really good wastewater program, but I can't find some nice monitoring site like this. But it has been going on the decline. This is the last 6 months. I'm showing out the total results. So you can see it was declining nicely. And most places in the U.S. regionally, it's the same thing. Where I live in Middlesex, it was going up, but now it has a steep decline. And you can see that the wastewater is showing that it's this EG.5. They don't have HV.1 separated out, but it is coming from this, would be coming from this area here somewhere. But the good thing is now it's in a decline. They're now, BioBot was doing every 2-week update, but now they switched to every week, I think, because of the case numbers. They're potentially going to go up. So I guess we have to monitor now in the next couple of months, see what happens. You could go here and look at your county, what's happening. You see here is HV.1 and EG.5 that was kind of stagnant up, but HV.1's taking over, as you see. It's regional. And you can see that HV.1 is coming from EG.5. That's why when I said here for the wastewater, if you want to really separate it, HV.1 would be somewhere in this yellow color or mustard color. But again, the good thing is if you did get your new booster, it's all here. You will get nice protection for these HV.1, EG.5, and so on. So encourage to get your booster if you have it.
So did one they mentioned earlier, option that they were worried about the HV.1 and the current vaccines, but now it's pretty solid that it covers those two?
No, so the one was, I think it wasn't maybe today, it was the other one, that BA2.86 is the one that was a concern, which is not on here. Yeah. So that one in the US is relatively low. And there was another strain in Europe and France that was popping up. I forget which one it was. I have to go back to last week. But that one is a concern of the back.
I probably got them confused with you.
Yeah. Well, so many variants now. It's like a variant soup, right? It's hard to keep a track of which one's which, nowadays. The dominant one in the U.S. is this HV, which is the boosters do a pretty good job to supposedly protect against. There's been some papers that shown that now. But there's that BA2.86 that's of a concern that's still relatively low and luckily hasn't taken off. But there's another variant in Europe. I forget what it's called, FL something. I forget what it's called. That could be of a concern if that takes off too.
And do we know enough yet about the pathophysiology of the HIV-1? Is it about like the other strains we've faced since the original? I mean, not as aggressive, but
I don't know. Yeah, I mean, from what I've seen, it seems to be the same. Yeah, you get the same outcome as you would from the original XBBs, from what I've heard.
Okay.
Yeah, there hasn't been any new pathology or new outcomes or symptoms that I've heard of that popped up unless someone else has. But I could be missing some things that people know. And again, I always show this one at the end. Of course, the case reporting is you don't even look at that anymore since no one reports cases. But the hospital admissions is what I would look at, and the ICUs. You see it's going down in the U.S., but not every country reports that as well, unfortunately. So, yep, that's it for today.